Hello children, welcome to Zero Panic Maths. Okay, in today's session, let us continue our discussion on the problems of exercise set 4.2. In the previous session, we have seen exercise set 4.1 and also as part of introduction, we have seen the two important identities a plus b whole square and a minus b whole square. Okay, if you have not watched that video, you watch that video because that formula, or you can say the identities discussed in the previous session, are required here to resolve this exercise set 4.2. Okay, now let us quickly start with the first problem. It is for factorizing the given algebraic equations here. Okay, we have to factorize this by using the identities that what we have studied in the previous session. Okay, now let me just rewrite this algebraic equation in the form of a plus b whole square and the expanded version of that. Okay, so this is actually the expanded version of that. 9x square plus 24xy plus 16y square is the actual expression given. Okay, but I can rewrite this as, instead of 9, I can write it as 3x and whole square. I can do this way because it is in turn 3 square, which is 9, and x square, which is x square. So 9x square, I have just written it as 3x whole square. Okay, so what I am trying to do here is I am trying to write this given expression in the expanded version of a plus b whole square. What is a plus b whole square? It is a square plus 2ab. So I have just written a square. I can write now as 2a. I have already written. What is the value of a? That is 3x. Okay, so now I have 2 into 3, that is 6x. 6x among 24xy, 6x I already have. So to make it 24xy, because I'm writing the middle term here, okay, just be concentrated here. I'm writing the middle term and I have 6x with me, but here it is 24xy. So first of all, I need to multiply this 6 with 6 fours, and then to make it xy, I need y also. So this makes it as a 2 multiplied by a and b. So this is b, so I can write directly this as b square, which is 4y whole square. Now you can verify that 4y whole square is actually 4 square, that is 16, and y square. You understood this, right? So it is now in the form of a square plus 2ab plus b square, where a is equal to 3x and b is equal to 4y. Therefore, the factors, this one, the exact expanded version, I can write it as 3x plus 4y whole square, which is a plus b whole square. Therefore, the factors of this expression are 3x plus 4y and another 3x plus 4y, because it is the whole term is getting multiplied twice. It is square here. So therefore, the factors are there are two factors, and those two factors are similar factors only, 3x plus 4y and another 3x plus 4y, which is 3x plus 4y whole square. You can write it this way or this way, because these are the two different factors which are equal to each other. Understood, right? So this is how you need to factorize it, by using the identity a plus b whole square. Okay, now let us do the same thing here also. Here also you can see that 4 is a perfect square. Whenever there is a perfect square, we can do that easily. Okay, so I can rewrite similar to here 9x square. I can write it as 2s. So here the variables are, instead of x and y, it is s and t. Okay, so 2s whole square, which makes it 4s square, plus 2. Blindly I need to write 2 because it is 2ab in the middle term. So I can just write it as 2 and a. I have already derived that it is 2s. Okay, so now if you multiply it, 2 into 2, it is 4s, but it is 20st. So first of all, you multiply a constant to make it 20. So 2 2s are 4, 4 5s are 20, and s is already there, you can give t. So this makes it as the value of b. So I can write it as 5t whole square, and that is b square for me, which is 25t square. Hope you are getting this. Okay, so here you can say here a is equal to, what is a value is 2s and b value is 5t. So therefore it is equal to 2s plus 5t whole square, which is a plus b whole square. Okay, so what are the factors? You can write that. Therefore the factors are the same thing written twice. Okay, 2s plus 5t and another 2s plus 5t. Now why I am writing this in this way? Because you might sometimes you will get some examples later on where you might get one factor is different from the other factor. So we'll see some examples of that kind also. Okay, so this is the second problem. Quickly we'll go to the next problem. Next problem is, again, see, 49 is a perfect square, 4 is also a perfect square, so we can easily do this also. What is 49? 49 square is the square of 7, so I can write it as 7x square. Okay, so a is now 7x. Okay, now I can write it as 2 and a value is 7x, and it is now 2 sevens are 14, 14 twos are 28, so I can write it as 2y, because x is already there. To make it xy, I want a y. So now this makes 2y as the value of b. I can directly write it as 2y whole square, and which makes it 4y square. Hope you are getting this. These are all similar examples only. So you can write it as where, or here you can say where a is equal to 7x and b is equal to 2y. Therefore it is 7x plus 2y whole square. Okay, hope you will write this next step. The factors are, okay, so let us save that time of writing this factors are statement. Let us write yourself 7x plus 2y once and 7x plus 2y another time. This little bit saves time for us. Okay, let us do it for the fourth problem. Fourth problem, again the first term and the last term you can observe that 64 is a perfect square of 8 and 4 by 9, though it is a rational number, the numerator 4 is a square of 2 and the denominator 9 is also a square of 3. So you can always write it as 2 by 3 q square. Okay, you can do that. So let me write 64 as 8p whole square. It is 8 8 is a 64p square. Now 8p is the a value for me, so I can directly write this first 8a 8a. Now to make it 32 by 3 pq, p is already there here. Okay, just see here and concentrate. To make it 32 by 3, what do I need? What do I need? See, it is already 16. So first of all, I need 2s. Okay, 2q, you can say 2q. So it makes it 8 2s are 16, 16 2s are 32. Okay, but I have a 3 also here, so I can do this as 2 by 3. So you see that now 2 8s are 16, 16 2s are 32 and divided by 3 and p into q, pq. So now it makes 2 by 3q as my value of b. So I can directly write this as 2 by 3q whole square, and which makes it as 2 square, which is 4, and 3 square 9, and q square. It is 4 by 9 q square. You understood this, right? Okay, so this is the way that you first write the given expression into the expanded version of any given identity. The identities that what we have studied till now are only two: a plus b whole square or a minus b whole square. You need to make use of only those two identities for these kind of problems currently. Okay, so here you can say a is equal to 8p, and what is b? B is 2 by 3q. Correct? So what is a plus b whole square then? It is 8p plus 2 by 3q whole square. So therefore the factors are again the factor, and unless you get two different factors, the factors remain the same value, 8p plus 2 by 3q and another 8p plus 2 by 3q are the two factors. You can write that yourself. Okay, so this is about the fourth problem. Let us quickly move to the fifth problem. Fifth and sixth, maybe six problems are there here. Let us see that. Okay, now this problem number 5 and 6 are little bit different, because you see that 3 here and 4 by 3 here are not perfect squares. 3 is not a square of any number. Okay, so we have to first convert these first term and the last term, or you can say the coefficient of a square and coefficient of b square, as two perfect squares. Okay, so that we can easily write the expanded version of the given identity. Okay, so what do I do is, let us multiply this whole expression by 3 first. Okay, so later when you get the result, we can again divide it by 3, so that to convert it to the actual value. Okay, so first I will multiply by 3. What it does is, it actually cancels this denominator 3. Okay, so let me do that. Multiply by 3. Why I am multiplying by 3 is, when I multiply by 3 to this whole expression, 3 multiplied by 3a square, it actually makes it as 9a square, and which is a square. I can easily write this as 3a whole square. Okay, plus 3 into 4ab, it is 12ab, it will give me. Let me write this first. Okay, what I am trying to do here is, when I multiply 3 to all these terms, here what happens is 9a square. Okay, and 4 3s are 12ab it is. And now see, this 3 and this 3 will get cancelled, and what remains is 4b square. You understood, right? Okay, now you can see, now 9 is a perfect square, 4 is a perfect square, so I can easily write this as 3a whole square, where 3a is the value of a now. Okay, so now what is the middle term? 2 multiplied by 3a, which is the value of a. It is 2 3s are 6, but it is 12, so 6 2s are 12, and b, it is 2b. 2b is the value of b for me. Now I can write that as 2b whole square. That makes it 4b square. Hope you are getting this. Okay, so now you can say that here a is equal to 3a and b is equal to 2b, so that you can write this as 3a plus 2b whole square. Okay, so therefore the factors are again 3a plus 2b and 3a plus 2b. You can write that yourself. Okay, now let us see problem number 6. It is again, see, 9 is a perfect square, but 5 is not. Here also the terms. Okay, now first of all, the terms given here are s and v. Okay, yes, v are the terms given. Okay, now or you can say variables given. But 5 is not a perfect square, but if I multiply 5 by 5, 25 will become a perfect square for me. So let us multiply the whole expression by 5, so that the 5 in the denominator of s square will get cancelled, and the 5 in v square will make it as 25, so that I'll get a perfect square. You're getting my point? Why I'm multiplying this by 5? You have to identify such a number, multiplying or dividing by which will actually make the a square and b square terms as perfect squares. Okay, that is the reason I'm multiplying it by 5. So let me multiply this by 5, and that is 9 by 5 s square. S and v are the variables here, as I already told. 6 s v plus 5v square. Okay, now when I multiply this 5 and 5 will get cancelled, and it remains with 9 s square. 5 6 are, that is 30, and s v plus 5 5s are, that is 25 v square. Okay, now 9 is a perfect square of 3, so I can write it as 3s whole square plus 2a. What is a? A is already 3s. Okay, so 2 3s are 6, 6 5s are 30. So I need a 5 with v as the variable along with it. So 5v is the value of b for me. So I can directly write it as 5v whole square. That makes it 25v square. Okay, so what is a value here? Where a is equal to 3s and b is equal to 5v. So what is the identity we are using? Again, a plus b whole square, where a is 3s and b is 5v and whole square. So the factors are 3s plus 5v and 3s plus 5v. You can write it yourself here. Actually, I forgot one thing here, that since I multiplied by 5 to the given expression initially, I have to divide this final answer by 5 so that I can just revert back this multiplication of 5. I'm sorry. So this is one small correction, that therefore the factors are, you should be writing the factors as 3s plus 5v, 3s plus 5v, another 3s plus 5v, okay, and multiplied by sorry, it is already multiplied, so you can divide it by 5. Okay, so there's just to make this correction, that because we have multiplied by 5, the final factors should be divided by 5. Okay, because we are reverting that multiplication. The same thing applies here also. We have multiplied by 3, so I have to divide these factors by 3 so that I'll get that reverting of multiplication of c. Okay, so therefore the factors are, you can say the factors are 3a plus 2b, okay, and another 3a plus 2b, and divided by 3. Okay, because we have multiplied it by 3. Okay, so this is an additional step that you need to remember if you have done any modification to the given expression initially. Okay, okay, now let us see the next set of problems. Okay, now in the next set of problems, you can see that they have already given the identity to be used to calculate the values of 79 square, 193 square and 299 square. Okay, now they have clearly mentioned that this is the identity to be used, so we can go by that process only. Okay, now we need to write 79 square as 80 minus 1 whole square. Okay, so that it is converted into the form of a minus b whole square, where a is 80 and b is 1. You know that, right? Okay, now why are we writing this in terms of the multiples of 10? Because if you write it in such a way, then it will be easy for us to calculate the squares of those and do the similar multiplications. Okay, now let me do the expansion of this. A square minus 2ab plus b square. A square here is 80 square minus 2a is 80 and b is 1 plus 1 square. Okay, so I've written it in the expanded version. Now you see that it is easy to calculate 80 square rather than 79 square. 80 square is 8 8s are 64 and followed by 2 zeros. That's the reason we converted in this format. You understood, right? Now again, multiplication of this 8 2s are 16 and followed by 0, that is 160, multiplied by 1, it is 160 only. Now it is 1 square, which is 1. Now from 6400 you can just subtract 160 first and add 1 to it. So first subtract 100, 6300, 6200, 40 and 1. So it is 6241, which is the square of 79 wholes 79. Okay, so you can multiply 79 by 79 and see to it that whether it gets the value 6241 or not. You can verify that for yourself. Okay, so here also the roundabout, the multiples of 10 is 200 here. So I can write it as 193 as 200 minus 7. Okay, where 200 is A and 7 is B. Okay, let me write that as expansion of a square minus 2a, which is 200, okay, and b is 7 plus 7 square, which is 49. Later we can do that. Okay. Again, 2 2s are 4. Okay. But there are already 2 zeros. So that will make it as 4 zeros, which is 40,000. Okay. Minus 2 2s are 4 followed by 2 zeros, that is 400. Or you can say 2 2s are 4, 4 7s are 28 followed by 2 zeros. You can say that. Okay. That is 2,800 plus 49. Okay, that is 7 square. Subtract 2,800 first from 40,000, which is first subtract 2,000 first, which makes it 38,000, and from 38,000 if you subtract 800, it will be 37,200. Okay, and plus 49, this one. Okay, now that makes it as 37,249. Okay, which is a square of 193, and you can verify it by multiplying 193 by 193. Let us do the same thing here in the third problem also. Here it is 300 minus 1, which makes it 299. Okay, so 300 is a little bit bigger number, but we can calculate the square easily. Okay, a square minus 2a, that is 300. Okay, and b is 1 here and 1 square, it is b square. 300 square is 9 followed by 4 zeros, that is 90,000, you can say. Okay, minus 2 into 3, that is 600 followed by 2 zeros, multiplied by 1, it is 1, and 1 you can keep it as. So 90,000 minus 600 is 89,400. Okay, and added 1 to it, you can write it as 89,000. Finally you'll get 89,401 as the answer to 299 square. Okay, so you can verify all these answers. Let us see any more. Okay, so there are no questions. So this completes the exercise set 4.2. Okay, let us quickly see more identities which are based on a plus b whole square and a minus b whole square. Okay, now you might have seen the another identity a plus b plus c whole square either in this year or in the previous year only. But how can we find out the value of an identity a plus b plus c whole square? And that is by using the given identities only, available identities which are a plus b whole square. Okay, now let us derive the expanded version of a plus b plus c whole square, which is another identity. Okay, let me write a plus b plus c. Okay, concentrate here. That what I will do is I will just write this b plus c or a plus b, any two terms, I will write it as one x term. Okay, so that I will get a value, this value converted into a plus b whole square. That is the thing that what I'm doing. Okay, let me write b plus c. Okay, let b plus c is equal to x. Okay, so that makes it as a plus x whole square. Fine. Okay, now it is in the form of a plus b whole square. I can write it as a square plus 2ab plus b square. So what is the expanded version of this is a square 2ab. 2a is a here. Okay, and b is x. Okay, plus b square is x square. Now replace x by b plus c here. Okay, now what happens? You can just see, just initially we considered x as the two terms, the addition of two terms b plus c. Now we are replacing back x as b plus c again. So that makes it as 2a, okay, into x is b plus c, correct, plus it is b plus c whole square. Fine. Okay, now let us expand. Just go on expanding it by the given identity a plus b whole square. Let us keep a square as it is, and 2a into b. Let us just write this distributive property 2a into b, that is 2ab, plus 2a into c, that is 2ac. Okay, plus this is done. This is middle term is done. Now again apply the a plus b whole square formula for b plus c whole square here, where a is b. Okay, so that is b square plus 2bc, that is 2ab plus c square. It's simple, right? Understood? Okay. Now all are expanded. Now we have to group together the square terms. A square plus b square plus c square. Let me write this as a square plus b square plus c square. Now write the products taken two at a time. 2ab, 2ab plus 2bc. Let me write this first, 2bc, and finally 2ac. 2ac or 2ca. You can write anything. Okay, so this is what the expanded version of this identity a plus b plus c whole square. You can write and remember this identity also. What is a plus b plus c whole square? Is a square plus b square plus c square. First the square of all the three variables, and then 2a into b, that is the product of the first two terms, then product of the next two terms, second and third, that is 2bc. Okay, and finally 2 times the product of first and last term, or first and third term, you can say, that is 2ac, or you can write even 2ca also. And this is what the result what we got here. Okay, so this is one more identity along with a plus b whole square and a minus b whole square. You need to remember this also. Okay, now let me see whether we have the visualization of this. Yeah, we have the visualization of this a plus b plus c whole square. You remember we have visualized the previous two identities, a plus b whole square and a minus b whole square, by using the geometrical shapes. Okay, now we have that also here, and you see that a plus b plus c whole square, we are going to prove that it is going to be this sum. Okay, how? Okay, let us have one square. Okay, and that square divided into multiple squares and multiple rectangles. Okay, now let us see, we have a line segment of length a here. This is a. Okay, this is a, this is b, and this is c. Okay, fine. And the similar thing here also, it is a and added with it is b and added with it is c. Okay, so there are three line segments, a, b, c. So what is the whole line segment length? Is a plus b plus c. This one, the outer square, just concentrate on that. Okay, since we have already seen such examples, the identities proofs already we have seen. So there is a line segment, the outer line segment, this is a plus b plus c, that is a plus b plus c. Understood, right? Okay, now let us first calculate the outermost squares area. What is that area? Is a plus b plus c multiplied by a plus b plus c. So that is equal to a plus b plus c whole square. You know this, right? Okay, we have seen such identities. Now that outermost squares area is sum of area of all these rectangles and all these trees. There are three squares. This is that one square, two square, and third square. Again, there is a rectangle here and there is a rectangle here. There is a one rectangle and rectangle. Green is a rectangle. This is orange is a rectangle. Red, yellow, and blue are the squares. Okay, now let us have the first area of all this. So the length of this square, side of this square is a and a. So the area of this is a square. You know that. Okay, so this is a and this is b, so it is a b. This is a and this is c, so this is ac. Okay, you can see that. Now this is a rectangle with one side as b and another side as a, so this is also a into b. This is a square with side b here. This is b. Okay, this is b because this is parallel to this. Just concentrate here. So this is b, so this is also b for me. So the area of this is b square, which is a square. Okay, now this is a rectangle with one side as c and another side as b here. So what is the area of this? Is b into c, bc. Now similar to that, area of this is a and this is c. So what is this? AC. Okay, you can see that, right, written here. Okay, now this is B parallel to this. This is B, and what is this? This is C. This is C. So it is BC. Okay, now finally this is a square with side as C and C. So it is C square. Now the area, the outermost square's area, which is equal to a plus b plus c whole square, is equal to the areas of all these rectangles and squares. Let us write them in order of the squares first and then rectangles. Okay, let me write this first. A square plus b square plus c square, squares of the area of the squares, that is a square plus b square plus c square. Okay, now we have a rectangle AB as a area and another rectangle with same area, that is AB and AB, that is 2 times AB. Okay, similar to that we have the rectangle with side area as BC, and we have another rectangle, the green rectangles, you see that BC BC. That's the reason they have already given filled it with the similar color, which have the similar areas. AB AB similar area, BC BC similar area, so it is 2 BC. Okay, now and finally we have 2 times of AC also. You can see the dark blue color, it is AC, that is 2 times of AC, and this is how we got this identity a plus b plus c whole square as this one. Okay, so this is how you can visualize the identity, this one. Okay, the variables, the square of the sum of 3 variables. Understood, right? Okay, now let me see whether we have an example of this kind. Okay, now let us have some worked examples or solved examples, which are to calculate some arithmetic problems using the identity a plus b plus c whole square. Okay, now let us write 119 square as, see, 100 first. Okay, and then 10, see, multiples of 10 I'm writing, and finally I'm writing a 9 and whole square. Okay, I think you got this point. It is 100, 110 and 119. Okay, where a is 100, that is a square. Okay, 100 square plus b square, that is 10 square, and c square, that is 9 square. It is a plus b plus c whole square. Okay, so the first 3 terms are done. What is next? 2ab. What is a? A is 100. What is b? B here is 10. Okay, plus 2 times bc. Okay, it is 10 into 9 plus 2 times ac. Okay, that is 2 into 100 into 9. Or else what you can do is you can just modify this expansion as like this, so that it will be easy for us late in the later stages, that I can just keep the square terms as it is, and from the product terms you can see 2 is a common thing here, so I can just write it as 2 times of, instead of just repeating that 2 for all the products, I can just say take 2 common and 2 times of AB plus BC plus AC. So this is also the same thing. Okay, so we can make use of this also for some of the examples. Hope you are getting this. Okay, so okay, anyway, for this problem I have written like this. For later problems we can make use of the later version of the identity. Okay, now what is 100 square? Is 1 followed by 4 zeros, correct? So that is 10,000. What is the 10 square? Which is 100, plus 9 square is 81, plus 2 into 100 into 10. Okay, it is 200 into 10, which is 2000. Okay, or 2 followed by 3 zeros, you can say. Okay, it is 2 tens are 20, 20 nines are is 180. Okay, plus 2 tens are 200 and multiplied by 9, or you can say 2 nines are 18 followed by 2 zeros. Okay, let us sum up all the thing and we'll see what is the result that you are going to get. Okay, 10,000 plus 100, that is 10,100. Here it is 2000. Let us first add here. Okay, that is 12,000, 12,100, 12,100, 13,900. Okay, 13,900, and then it is 14,080 and 14,161. It is 14,161, which is the square of 119. Okay, you can verify this and verify the sum also. If there are any calculation mistakes or some mistakes, you can just verify and make that correction. This is the example which is based on the identity a plus b plus c whole square. Okay, so there will be some exercise set which are based on that only. Here in exercise 4.3, we are applying the formula a plus b plus c whole square that we have just studied. Let us read the first problem set, that is, find the following squares using one of the above identities. Above identities are those identities that what we have studied till now, including a plus b whole square, a minus b whole square, and the just studied a plus b plus c whole square. Using those three identities, we need to determine or calculate these arithmetic calculations, making it easier by using the identities. Okay, determine which of the identities will make these calculations easier. Among the three identities, whatever identity makes our job easy, we'll make use of that identity here in calculations. Okay, now as you can see it here, we have just seen one example of 119, which we resolved it by expanding 119 as 100 plus 10 plus 9. The similar way we will do this also by using a plus b plus c whole square. Okay, now let us rewrite this as 100 plus 10, that is 110, and remaining is 7. So we know that this formula. You can write it, or I will write it once, you can remember this. Okay, so the formula that what we are trying to use here is a plus b plus c whole square. There are three variables here. Okay, and the formula corresponding to this is a square plus b square plus c square plus 2 times ab plus bc plus ca or ac, you can say that. Okay, so this is the formula that what we are going to use here, and we have already written the left side part of this, a plus b plus c whole square, and that is equal to 100 square, which is a square, 10 square, which is b square, 7 square, which is c square, and 2 times of 100 into 10, that is ab. Okay, 100 into 10 is ab, plus 10 into 7, that is bc. Okay, and finally 100 into 7, that is AC. Okay, now just go on expanding or calculating the exact values of the squares. Okay, 100 square is 1 followed by 4 zeros, that is 10,000. 10 square is 100, we know that. Okay, 7 square is 49, we can directly write it. Okay, and then finally 2 times of, let me write it here. Okay, 2 times of 100 into 10, that is 1000. Okay, and 10 into 7, that is 70, and 100 into 7 is 700. Okay, so the total of all this will be equal to 13,689. You can calculate by summing up all these. This will lead to 13,689. If there are any mistakes in the summing up things, you can correct those things. But what you have to understand here is what identity will help us in making our calculation easier here. Okay, that is the thing that you need to understand. Let us calculate quickly for the second also. Here it is 78 square, so that I can write it as 70 plus 8 whole square, and as we know that this is a simple identity, a plus b whole square. Okay, so what is a plus b whole square is a square plus 2ab. What is a here is 70 and b is 8 plus b square, that is 8 square. 7 sevens are, that is 49, and followed by 2 zeros, that is what 70 square is. Okay, so 2 sevens are 14, 14 eights are is 112 and followed by this single 0. 1120 8 are it is 64. If you sum up all these, it is 4900 already. So if you add 1000 to it, 5900, it is 6120 and 6084. It is 6084 is the answer to this. So this is a simple sum by using the identity a plus b whole square. Let us quickly move to the next problem because these are all the similar problems. I will go a little bit faster. Okay. So here 198, which is nearer to the roundabout 100 figure, is 200. 200 minus 2 whole square. And as you know, this leads to the identity a minus b whole square. Okay. So let me write that once because it will be little bit different. 2ab plus b square. Okay, there will be a minus to the middle term. So let us write what is a here is 200. 200 square minus 2a is 200, b is 2, okay, and plus 2 square, that will be 4 later. Okay, so 2 twos are 4 followed by 4 zeros. Okay, that is 40,000 minus 2 twos are 4, 4 twos are 8 followed by 200 2 zeros and 4 finally. So from 40,000, if you just deduct 800, it will be 39,200 and it will be plus added to it. It is 39,204. So this is the answer for 198 multiplied by 198, that is 198 square. Okay, now let us quickly move to the next problem, which is 214. So as you can see here, 214, I can divide it into 200. Okay, it is a multiple of 100 and another multiple of 10, 210 plus 4. So it is a plus b plus c whole square. Okay, so that you need to write. If you want, you can write that formula here. I'm going to write it directly because I know that formula now. Okay, so but if for your reference examination purpose, you can write that and make a square or underline that formula that we are using this formula. Okay, or identity, you can say a square. Okay, you know that formula, a square plus b square plus c square, that is 4 square, and 2 times of ab. Ab is 200 into 10. Okay, and bc is 100 into 4 and CA or AC is 200 into 4. Okay, so this is what the formula. Now 200 square is 2 times 2 twos are 4 followed by 4 zeros. Okay, it is 40,000 again, and 100 for the 10 square and 16 for 4 square plus I will write it in the next line here. Okay, it is 2 times of 200 into 10, that is 2000. Okay, plus 10 into 4, that is 40, plus 2 fours are 8 and that is 800. First sum up these things, that will be 40,116. Okay, 40,116 or 116 you can say, and 2 times of whatever sum that you get inside, 2,800 and 40, 2,840. Okay, so 2 times of 2,840, you can sum up that, it will be 40,116 plus 2 zeros are 0, 2 fours are 8, 2 eights are 16, 1 carry, 2 twos are 4 and 5 it is. Okay, so if you sum up 40,000 and 5,000, it is 45,000, 45,680 and 45,780, 796. Okay, so it will be 45,796. 796. It is 45,796, which is square of 214, which you may get it by multiplying 214 to 214 itself. Okay, let us quickly see the next problem. So next problems are also making use of a plus b plus c whole square formula only, but these are a little bit bigger numbers. Okay, so let me just expand it in the form of a square plus b square plus c square and the expanded version. Okay, and you can make sum of that and you can calculate the final value. Okay, I'm not going to spend time on it because it is the similar problem that what we are resolving here. Also I can write this as first of all 1000. Okay, it is 1104. So next b I can write it as 4 and c I can write it as 4. Okay, okay, sorry, a is 1000, b is 100 and c is 4 and whole square of that. So again 1000 square, okay, it is a square, 100 square which is b square and 4 square, okay, that is c square, and 2 times of 1000 into 100, that is ab. Okay, bc is 100 into 4 and finally ac is 1000 into 4. Okay, so if you have the square of 1000 is 1 ones are 1 followed by 6 zeros. Okay, it is 6 zeros, 3 4 5 6, it is 1000 square. 100 square is 1 followed by 4 zeros and 4 square is 16 and plus 2 times of whatever value that you get inside, 1 ones are and 5 zeros, 1 followed by 5 zeros, 3 4 5 plus 100 into 4, that is 400, and 100 into, sorry, 1000 into 4, that is 4000. So it is all in terms of the multiples of 100 or multiples of tens only. You can just sum up all these things and write the final answer, and that will be the square of this. I'm just giving you the expanded version of this. You can make this calculation. It's only the sum that is remaining now. Similar thing we will do it here also, that we will write 1120. Here it is 1104 and it is instead of 04 it is 20. That's all the difference here is. Okay, I don't know, very similar kind of problems they have given it here. Okay, so it is 1000 plus 100, it is 1100. Okay, 1100 and 20. Okay, it will be 20 whole square. Now write a square, that is 1000 square, as it is in the previous example only. Okay, b square is 100 square and c square is 20 square instead of 4 square over there. Okay, it is the exact similar problem as compared to the previous problem. Okay, now plus I can write it as 2 times of 1000, sorry, let me write it correctly, 1000 multiplied by 100, it is AB, and BC is 100 multiplied by 20 plus AC is 1000 multiplied by 20. Okay, sum up all these things. Again, you know that 1000 square is 1 followed by 6 zeros, 100 square is 1 followed by 4 zeros, 20 square is 400, and 2 times of this. The final answer to the square of 1120 is 12,54,400. Okay, so you can calculate this sum and compare it with this value or not. Okay, whether you get that value or not. Similarly, we will have the answer for this also, that square of 1104 is 12,18,816. Okay, so you after calculating the sum, you compare your answer with this value. Okay, whether you get that value or not. Okay, let us quickly move to the next problem. Now looking at the second set of problems is to factorize using the suitable identities. Okay, now such kind of problems, if you remember, we have already done it in exercise set 4.1. okay, and 4.2 even also, and in some of the solved examples also. Let us use the same trick here also. Okay, now usually these expressions are given in the form of expanded versions of the given identities. We need to identify A and B so that we can write the short version of that identity. Okay, now let me write this 16y square as 4y whole square. Okay, you remember I have written such problems. We have already done such problems. So here a is 4y. Okay, so when I got the value of 4y, I can write 2ab. So I have the two constant and a already know 4y. The middle term I am writing, and the middle term already I got is 2 4 the 8 8y, but here it is 24y. So to make it 24y, what I require is 2 4 the 8 8 3 za, that is 24. I just need 3, okay, to make it 24y. So that I got the value of b as 3. So I can blindly write this as 3 square, and that will definitely match the last term, that is 3 square. Okay, that is b square now for us. Okay, so here 4y is a and 3 is b. Okay, so you can write that. We know that I can write the expanded version only, a square minus 2ab plus b square, because it is now it in this form. We know that this is equal to a minus b whole square. Okay, so I've just written the swapped version of the given identity. So now I have this, so I can easily write this. Okay, so it is 4y minus 3 whole square, where a is equal to 4y. Okay, where a is equal to 4y and b is equal to 3. Okay, so therefore it is the factorization is required. So therefore the factors are, you can write that factors are, we know that, right? So if there is a square here, we have to write the same value twice, and those are the two factors which are equal to each other. Okay, so these are the two factors of this algebraic equation. You understood this, right? The similar thing we will do it here also. It is a square plus 2ab plus b square format it is now. Okay, so let me write 9 by 4, and since you know that 9 and 4 both are the perfect squares of 3 and 2, I can write it as 3 by 2, and instead of x and y or a and b, the variables here are s and t. So let me write that as 3 by 2 s square. Okay, which gives me 9 by 4 s square when you apply square to the whole term. Okay, so I've written a now, and I can write a 2ab. Okay, 2 I've already written, a I know that it is 3 by 2 yes, and what is required to make the middle term as 6t, 6st. Okay, so 2 will get cancelled, so I need another 2 to make it as 6 constant, that is 2. And to make the st, I have already t, I sorry, yes I already have, and I need t. Okay, so now if you check, 2 will get cancelled, 3 2s are 6, and s and t is st. So this is 2a and b. What is b now? 2t. So I can directly write it as 2t whole square, and that makes it as b square, which is 4t square, which is there here in the last term. Understood, right? Okay, now let us write. So this is the expanded version of this. So we can write that we know that a square plus 2ab plus b square, and that is equal to a plus b whole square. So I will be writing this whole thing in the form of a plus b whole square, and that is 3 by 2 yes, that is a, and plus 2t, that is b. Okay, so where you can write it as a is equal to 3 by 2 yes, and b is equal to 2t. Okay, and finally the factors are, so therefore the factors are, can you write this? Factors are the whole term written twice. Okay, you can write it to yourself. Okay, so this is how you are making use of the identities to factor the given algebraic expressions. Okay, let us quickly see the next problem. Okay, now you can see the next problem given here. The third problem is making use of the identity a plus b plus c whole square. There are three terms, three variables you can say, and those are m, k, and n. Okay, so let me write this in the expanded version of a plus b plus c whole square. Okay, and you remember what is a plus b plus c whole square? It is a square. Let me write that a square as m by 3 whole square. So that gives me m square divided by 9. Is it correct? Okay, and b square, what is b square here is k by 2. So you just look at the square terms first. Okay, so here it is 2ab, 2bc and 2ca. Okay, but it is b square for us, and that makes it k by 2 whole square. So k by 2 is b here. Are you getting my point? Okay, a is m by 3, k by 2 is b. So it is k square by 4. Again, the c square term is there here with 9n square. So I can write it as 3n whole square, which gives me 9n square, making the c value as 3n. Understood this? Okay, so let me write what next is 2ab, 2bc, 2ca or 2ac. That you need to write those three product terms. Okay, so it just go on writing it. Okay, 2ab, what is a? Don't look at these terms, you just go on, because you have a b c values here. You can just write this as 2ab. What is a? M by 3, and what is b is k by 2. Okay, so it is m by 3, m by 3 and k by 2. You see whether after cancellation of this 2 and this 2, mk by 3, where it is mk by 3? See, this is 2ab, this term is 2ab, so I have mk by 3 also, that is 2ab. You're getting my point? I did not look at this term, but I have written that term just by considering the expanded version term, that is 2ab. What next is 2bc? So let me write that also first. What is b now? K by 2. Okay, and what is c is 3n. You see whether there are any terms like that. 2 and 2 will get cancelled here, and kn, 3kn, see, or 3nk. See, that is that term. It is 2bc term. It is a 2bc term. You getting my point? Okay, it's so easy to write that. Okay, so and then 2 ca or 2ac. What is a? M by 3, m by 3. Okay, and what is c? C is 3n. Okay, just I'm writing it here, just make a note of it. This 3 and 3 will get cancelled, and what remains is 2mn. See, this is 2m. You got it right? So you don't have to worry about the terms. If you are not getting any of the terms of algebraic equation after writing the expanded version of that, then there is some mistake that is there from your side, or there is a different expression given here in the problem that you need to confirm. You understood, right? So hope you got this point. Okay, so now we know that this is the expanded version of, so let me write that we know that a square, because we have written it in this format, I'm writing that a square plus b square plus c square plus 2ab plus 2bc plus 2ac is equal to what is that? A plus b plus c whole square. Okay, we know that this formula. Okay, so I'm writing that in the expanded, sorry, we have already the expanded version. We have to write this short form, considering a as m by 3. Okay, so therefore it is m by 3 plus what is b? B as k by 2. Okay, and what is c? C is 3n. Okay, whole square. So this is actually the factor. So you can write that where a is equal to, hope you can write that where a is equal to m by 3, b is equal to k by 2, and c is equal to 3n. Okay, and finally you can write that the factors are this multiplied by this another term. Okay, hope you can write that. Okay, I've done it till the solution. You can just write the last statement. Okay, let us look at this problem quickly. Okay, it by looking at the problem you can get that it is a square minus 2ab plus b square format. Okay, so let me write that as p by 4, because 16 is also a perfect square. I can write it as p by 4 whole square, which gives me the value of a as p by 4. It is p square by 16 minus 2a. So I told you that you have to just go on writing 2ab. A is p by 4. I know that p by 4. Okay. So see, the middle term is only 2. Middle term is only 2. Leave about the minus, because that minus I have already written. The corresponding minus is also there. Okay. So just look at the value. It is only 2 I have. So I already have 2, but by 4 I have an extra value. So to make the middle term as 2, I have to cancel this p and 4 both. So I have to write it as 4 by p, so that this p 4 and 4 will get cancelled and 2 only will remain. Okay. So what does it gives me is this is the value of a and this is the value of b. I can directly write it as 4 by p whole square, and just check whether it has b square here. See, 4 square is 16 and p square is p square. So 16 by p square is the last term given, making it giving us the value of b. Okay. So we know that you can write it again. We know that a square minus 2ab, this is the format we have already written. Okay. This is the expanded version here. Okay. And that is equal to a minus b whole square. So therefore it is p by 4. P by 4 is a. Okay. And minus 4 by p, the reverse of that. Okay. 4 by p is our value of b. Okay. So where a is equal to p by 4, where a is equal to p by 4 and b is equal to 4 by p, the reverse of that. Okay. So therefore the factors are, you can write that factors are p by 4 minus 4 by p and another p by 4 minus 4 by p. Okay. Hope you can write that. So this is the fourth problem. Let us look at the fifth problem. That is also, so looking at this problem, it also coincides with the expanded version of a plus b plus c whole square only. But there is a small change that you can observe here is, instead of giving all plus values, there are two terms of the product terms which are given in negative terms, that is this one and this one. But negative terms are not there in our formula that what we have studied, or the identity does not expand any negative terms. Okay. But how do we manage that is the trick here. Okay. Listen to me this carefully. Okay. Look at the terms where you are getting the negative values. You see that 12a, a is there here and c is there. But what common thing you have is b. You can observe that in these two terms. Listen to me carefully. Okay. In these two terms, what common variable you have is b. Okay. So it means that it is the b value that is making the whole term as negative, that is minus b. That is actually minus b. Okay. Now why I'm explaining all this, because I'm going to write this as, you see, 9a square as 3a whole square, making it as a square. Value of a is 3a. Okay. Plus, while writing b, what I'm going to write is minus 2b whole square. Minus 2b, I'm making it as the value of b. Okay. So that gives you minus 2 into minus 2, that is 4. B into b, that is b square. So that actually gives you 4b square plus 4b square only. Okay. But keeping minus 2b here in the product term makes the whole term as negative, and that is making the difference here in these two terms. You got my point? So minus 2b is my value of b. Okay. C is as usual c only. Okay. Only c is the value of c. Okay. Now plus 2ab. I have to write 2ab. So let me write it as 2a. And what is a? A is 3a. And what is b? B is minus 2b. Okay. I have the value here. You see now the multiplication of all this is 3 2s are 6, 6 2s are 12 with minus. Okay. So minus 12a and b. You see that? Minus 12ab. So that is how I written it as in the form of plus 2ab. Hope you got this. Okay. Whereas the second term, that is 2bc. 2bc. Okay. So 2bc is actually this term. Okay. Let me write that also. Okay. 2bc. What is b? B is minus 2b. Minus 2b. And what is c? C is c only. Only c. Okay. So you see that 2 into minus 2, that is minus 4. Minus 4bc. Minus 4bc. This is the term which actually coincides with plus 2bc. Okay. And finally plus 2ca. 2ca or ac. AC is 3, sorry, a is 3a and c is c. Okay. See that it is 2 3s are 6, a into c, that is 6ac. So this is my 2ac term. This is 2ac term. So I've written it in the expanded version of a plus b plus c whole square, and that is a square plus b square plus c square, okay, plus 2ab plus 2bc plus 2ac, and that is equal to, sorry, and that is equal to a plus b plus c whole square. We know that. Okay. So this is the expanded version of this left side term we already have. So I have to write it in this format, including a as 3a and b as minus 2b. So I have to write it as minus 2b and c as c only. Okay. So where a is equal to, you can write that a is 3a and b is minus 2b, okay, with sign, okay, and c is equal to c. So therefore finally the factors of the given expression are this term, okay, that is 3a minus 2b plus c, another 3a minus 2b plus c. So these are the factors of this expression. Okay. So let us see the next problem. The third set of problem is actually the reverse of what we have done in the second set of problems. You see that in the second set of problems, we are given with the expanded versions and we are asked to find the factors of that. Okay. So these are actually the 2 times of a plus b plus c. Those are the actual factors of this expanded version. Okay. So we are doing the reverse of that now. We are actually given the left side and we have to expand this. That's all. We have to do it in the third set of problems. Okay. So here a is p, b is 3q, c is 7r. Okay. So you can write that because okay, you don't have to write it because they have already given. This is the identity that you must use it here in the third set of problems. So let me write that in the form of a square. Okay. So that is p square and b square, that is 3q square and 7r square. It is a plus b plus, sorry, a square plus b square plus c square plus 2 times of ab, that is p into 3q, okay, plus 2 times of, let me write it here, plus 2 times of bc, that is 3q and 7r, okay, and 2 times of ac or ca, you can say, and that is p into 7r. Okay, so just multiply all these terms, you will get the expanded version of that. So that will be p square and 3 square is 9q square, okay, 9q square, 7 square is 49 and we have r with it, it is 49r square. It is 2 3s are, it is 6 pq, okay, 6 pq is the value of 2ab. Now it is 2bc, 2 3s are 6, 6 7s are 42qr, 42qr is our 2bc, okay, and then 2 7s are 14pr, 14pr is our 2ca or 2ac. Okay, so this is what the expanded version of this. That's all, nothing more than this. Okay, so here also we have the different values of a b c. Okay, we have to write it in the similar fashion. Okay, so it is 3x whole square. Again we are, remember, again we are using the same formula. Okay, only the values of a, b, c are different here. A square plus b square. What is b square? B is minus 2y here. Okay, so plus c square, that is 4z whole square. Okay, plus 2ab. We know the values of a here. A is 3x and minus 2y. 3x into minus 2y, it is 2ab. Now let me write 2bc. What is b? B is again minus 2y. C is 4z. Okay, plus 2ca or ac. A is again 3x and c is 4z. Okay, just multiply it and that will give you the expanded version of this. So 3x whole square, that is 9x square. Okay, minus 2 into minus 2, that actually makes it as 4 and y square. Okay, so when you uh, multiply the negative number with itself or take a square of negative number, it is always going to give positive number only. 4 square is 16z square. Okay, and what is 2ab? 2ab, so here it is only one negative term, so I can write it as 2 3s are 6, 6 2s are 12, but that is minus 12. And what are the variables? X and y. So minus 12 xy. Next is again there is a minus here. 2 2s are 4, 4 4s are 16, that is minus 16, and variables are yz. Okay, and there are no minus terms, I can write it as plus here. 2 3s are 6, 6 4s are 24 xz. These are the expanded, this is the expanded version of this given expression by using this identity. Okay, let us look at the last problem of this exercise set. Okay, now here in the fourth problem they are asking us whether to find whether this expression given is an identity or not. You know that to say any equation as an identity, left hand side expression evaluation should be equal to right hand side expression. Okay, so if you expand the left hand side here and you exactly get 2a square plus 2b square plus 2c square, then it is an identity. Otherwise it is not an identity. Okay, because for every given values of a, b, c, the LHS should be equal to RHS, then only it is an identity. Otherwise it will be a contradiction. Understood this, right? Okay, so let us expand all these three terms given in the left hand side and let us see whether it is equal to the right hand side or not. So it is the identity a plus b plus c whole square that we are writing it thrice. Okay, see it carefully here. Okay, I'm writing it a square, that is a square, plus b square plus c square. I can write, though it is minus c, it will be plus c square only when we do it a square of the negative term. Okay, so now it is 2ab, so I can write it as plus 2ab. Okay, whereas minus 2bc, because c value is minus here, so I have to write it as minus 2bc. Okay, and again minus 2ac, because c here is minus, so minus 2ac. It is the expansion of the first a plus b minus c whole square. This is the expansion of that. You got this, right? Now I have to expand this. Here in this, b is minus, instead of c, b is minus here. So let me write the expanded version of this now. So a square, so square terms will be plus only, so I don't have to worry about that. A plus b plus c whole square. Okay, now while looking at minus 2ab, it is minus 2ab because b value here is minus, so I have to write it as minus 2ab. Again b and c will be the minus value only because b is minus here. Now a is not minus, c is not minus, so I can write it as plus 2ac. Okay, so this is the expansion of this middle square. Now finally here b and c both are minus, so I have to expand that by keeping it in the mind. Okay, so again square terms will never change. It will be a square plus b square plus c square. Now, while writing AB, it is minus 2AB because B is minus here. While writing BC, since both are minus, it will make it as plus. So it is plus 2BC. I hope you are getting it. Finally, in the product of A and C, it is 1C minus. So minus 2AC. So I have expanded all these three terms in one expression. Okay, so this is a single expression. Okay, don't write it as a, different steps. It is the one step single expression. Okay, now look at this carefully. What are the terms that will go on cancel each other? Okay, see, plus 2AB and minus 2AB. So there is a minus 2AB here, plus 2AB here. Minus 2BC and there will be a plus 2BC. See, there is a plus 2BC here. Minus 2AC, okay, and there will be plus 2AC. So all these terms got cancelled, and what remained is minus 2AB, minus 2BC, minus 2AC. So there are no contrary term to that, or you can say there are no positive terms to get these products cancelled. So I have to keep that products like that only. Okay, but now look at the square terms here. See it carefully. Square terms, a square plus a square plus a square. In all the three expansions, the a square, b square and c square terms will never get cancelled because all those are positive only. Okay, you're getting my point. So it is 1a square, 2a square, 3a square. Similarly, it is 3a square, and similarly b square terms, b square, b square, b square, it is 3b square. Okay, and finally it is c square, c square, c square, that is 3c square. And what remained with product? It is minus 2ab, minus 2bc, and finally minus 2ac. So this is what the left hand side. And what is right hand side here? Right hand side is 2a square plus 2b square plus 2c square. Okay, so it is the right hand side that we were expecting, but we did not get that. So what is the meaning of this? Is this is not an identity because LHS is not equal to RHS. Okay, you know this, right? Right hand side, sorry, left hand side is not equal to right hand side because we were expecting this expansion, but we got this expansion. So this given expression or equation is not an identity. Okay, so therefore the given equation, or you can say given expression or equation, not an identity. So let us see what next. So the next is to visualize another identity, that is a square minus b square is equal to a minus b into a plus b. This is another identity. Okay, so let us discuss this identity, and if there are any problems related to this, we will look at that in the next session. So we have completed the exercise sets 4.2 and 4.3 in this session. Let us look at these remaining things in the next session. Okay, thank you.